Okay, for the next section, we're going to be going out of the book a little bit. We're going to be doing sections 13.1 and 13.2, and they're going to have a combined homework assignment. You're definitely going to need access to the HP Prime calculator. So if you have yet to download the calculator, please make sure that you do so as soon as possible. Because you will need access to a scientific calculator that has the sine, cosine, and tangent function included. Okay? We're going to be starting off by working with trig ratios. So basically, a ratio is comprised of two sides of a right triangle. In fact, you can't use any of these sine, cosine, or tangents with any other triangles than right triangles. So they absolutely have to be a right triangle. Down here, we have sine, cosine, and tangent, and basically these are going to be almost definitions for that. And something that you may or may not have heard of before is a little acronym that will be very popular called SOHCAHTOA. Now, that's how we basically memorize what sine, cosine, and tangent is. So in a triangle, for example, you have an opposite, adjacent, and a hypotenuse. And the only way that you know how to label those things is they're going to correspond to an angle. So for example, if this is the angle that you have, this side is opposite of that angle, all the way across on the other side. The slanted side of a triangle is the hypotenuse. And the other leg that's right next and touching the angle that you're talking about, that is the adjacent side. So when asked to find the sine, if it was this angle, would simply be opposite over hypotenuse. That's what the OH means. Cosine would be adjacent over hypotenuse. And tangent would be opposite over adjacent. Now, please don't memorize the location of opposite and adjacent based off of this triangle. Because if I was asked to find it from this angle, then my opposite and adjacent would actually switch spaces. What you need to know is that opposite is across from the angle that you're talking about. Adjacent is just the other leg, and hypotenuse will always be the slanted one. Keep that in mind. Don't necessarily memorize this triangle because it could be flipped or turned, and maybe you're talking about the other angle in it in this sense. Let's go ahead and do a couple of problems. So for example 1, we're asked to write the sine, cosine, and tangent of each angle as a fraction. We're not going to worry about the decimal part, okay, guys? So we don't even need to worry about rounding either. Here we go. So to write these as a fraction, I am asked to start off by finding sine of A. And again, my acronym is SOHCAHTOA. Okay? So I know if I'm asked to find sine of A opposite of A is going to be all the way across on the other side. So opposite of A is going to be 18. And H stands for hypotenuse. Hypotenuse is always a slanted one that's across from the 90-degree angle. So my hypotenuse for this triangle is going to be 30. And again, my hypotenuse will never change. Regardless of which angle I'm talking about, my hypotenuse is always going to be the one across from the 90. Now I know that my answer is a fraction, so I just need to make sure that I have reduced all the way. I notice that both of these have a 2 in common, so I'm going to go ahead and divide by 2. Some of you may see an even larger number, but let's say we only saw 2. If we don't pick the largest number first, then you always just completely check your fractions each time. Is there another number that you can take out of 9 and 15? Think about it. What number can you take out of 9 and 15? 3, right? 3 also goes into both of these. So now I have 3 over 5, and that is the sine of A. Okay? So just make sure you reduce your fractions all the way. I'm not going to do cosine. I'll do cosine on the next one. Let's do tangent of A. So I'm still at the same angle over here, and tangent happens to be opposite over adjacent. So again, from A, opposite is directly across, right? All the way across. So my opposite is 18. Adjacent can't be the hypotenuse here, right? It can't be the opposite. It's the other leg that's directly connected to the angle. See how that touches the angle that you're starting from? So that's going to be 24. And again, just make sure you can't reduce. I want you to think a little bit more on this one. Is there a larger number that you can take out? What's the greatest number that you can think of that you can take out of both the numerator and the denominator? If you aren't able to think of it and you only see 2, then you go ahead and divide 2 and you continue to simplify. But actually, I believe 6 goes into both of these, right? So the bigger the number, the less reducing I need to do. So 18 divided by 6 is 3, and 24 divided by 6 is 4, and I can't go any further with that fraction. So the tangent of A is 3 over 4. Now let's see what happens when I switch the angle I'm talking about. Let's go ahead and find the cosine of B. So now let's say we're looking over here. In this case, my hypotenuse is still going to be exactly the same, but when I'm talking about opposite and adjacent, my opposite would be across. My new opposite would be 24, and my adjacent, the one connecting or touching my angle, is going to be 18. So just be very careful with that. That's what I meant in the last slide about not memorizing the triangle, because it depends on which angle you're looking at. All right, so we're asked to find cosine, which is adjacent over hypotenuse. So from this blue angle here, adjacent is right next to it, touching it, right? It's the leg, which is going to be 18 over hypotenuse, which is 30. And again, just always check to see if you can reduce your fraction. Again, it looks like both of these go into 6. If you don't see 6 and you see 2, you start with 2 and you continue to reduce as far as you can. Always check your final answer to see if you can go any further. Cosine of B is going to be 3 over 5. All right, let's go ahead and look at example 2. Find the unknown length x in each right triangle to the nearest tenth. So in this case, we're still going to be using the acronym SOHCAHTOA. So when we're using this, we got to look at the angle that's given and then look at the two legs that are given and decide what those two legs are into relation to that 37 degrees angle. So is x the opposite, adjacent, or hypotenuse? Is 11 the opposite, adjacent, or hypotenuse? That's the question that we need to ask ourselves. So looking at this problem, I'm going to start with my x. My x is going to be my hypotenuse, right? And my 11 is not the opposite. This is opposite over here. It's going to be the adjacent. So then I ask myself, which trig function, sine, cosine, or tangent is using adjacent and hypotenuse? So which trig function up here has an A and an H? Cosine, right? So I know cosine of some angle, in this case B, is adjacent over hypotenuse. So in this case, my angle that I'm looking at is 37 degrees. My adjacent side is 11, and my hypotenuse is x. Now, I need to solve for x. So I'm going to go ahead and multiply both sides by x. And I'm going to get x times cosine of 37 degrees equals 11. And to get x by itself, I'm going to go ahead and divide by cosine of 37 degrees on both sides. Now I'm going to go ahead and stop this video and start a new one where I can share my calculator with you. Or actually, I might be able to show you how to do this. 11 over cosine of 37. So I'm going to pull up my calculator. And if you guys have yours on your phone, I find that that's a little bit easier. It was 11 divided by cosine of 37. So first thing I want to do is I want to check and make sure that this green thing right here, this green button, is in degrees. Okay, so this green button next to the little battery sign, that has to be in degrees. So see how I have a little Celsius there? If it's not, you simply click on that and then you can change. This is radians with pi and this is degrees. I'm not sure how much in geometry we're going to get into radians, so most of the time it'll be in degrees. So if I remember correctly, my question was, or my answer was 11 over cosine of 37 degrees. Hopefully I got that right. So I'm just going to type it in here. I'm going to make sure that I'm in my home screen. Let me minimize this for a second. There we go. I like it better as like an actual calculator. Here we go. So I have 11 divided by, I'm going to click my cosine button, and it was 37. Hit enter, and sure enough, I get 13.77, blah, blah, blah. And the question says to round your answer to the nearest tenth. So my solution for x would equal 13.8. This is not a degrees. X was a side. So 13.8 is correct. All right. Let's go ahead and look at the next question here. Find the unknown length x in each right triangle. So we're going to approach this the exact same way. This is the angle that I'm given for this particular question. I'm going to ask myself, what is x and what is 13 in relation to 32 degrees? Is it opposite, adjacent, hypotenuse? What is it? So let's start with x first. Well, 32 degrees is here. This is directly across. This is known as the opposite side, right? 13 definitely isn't the hypotenuse, but it is touching the angle. So that is known as adjacent. So all I need to know is TOA. Going to glance at my trig functions and ask myself, which trig function uses O and A? Well, as I'm looking at my letters here, I notice that tangent is the one that uses O and A. So tangent of A in this case is opposite over adjacent. Well, the angle that we're talking about is 32 degrees. Opposite is x, and adjacent is 13. This one's a little bit easier to solve for because all I have to do to get x by itself is just multiply by 13 on both sides. So x is going to equal 13 times the tangent of 32 degrees. I'm going to show you one more time how to plug this into your calculator, and then you guys should be good to just check your answers with what I get. So let me 13 times tangent of 32. So here we go. I have 13 times tangent of 32, and it's still in degrees mode. And then I'm just going to hit enter. And I believe the question says round to the nearest tenth. So again, x would equal 8.1 for example 3. 8.1. All right, one more, I guess, for this example here. So for this, actually, you know what, that should be good enough. I'm just going to go ahead and give you a hint for this one. We have opposite and hypotenuse. So which trig function uses O and H? Sine, right? So go ahead and see if you could finish off that one. But what you should have is sine of 57 equals opposite over hypotenuse. Multiply both sides by x. You have very similar solving here that I did 2 examples ago. And then divide by sine of 57. All right, I'm going to go ahead and stop this video because I think I skipped one of the you try problems. So go ahead and try that now, and then I'll pick up with the next section.